What if astronomers had a chance to study more about the dark ages of the cosmic history for the very first time with a superpower telescope not on Earth or in the Earth's orbit, but on the Moon? Right after the Big Bang, our universe slowly cooled down and the very first atoms were formed. Gravity then gradually pulled together clumps of hydrogen and helium gas, which ended up forming some of the earliest stars that we know today. This era lasted about a few 100 million years prior to the large-scale formation of stars, which is now known as the cosmic dark ages. The Lunar Crater Radio Telescope is an ambitious concept to place a massive radio telescope on the far side of the Moon, which would then observe the universe during the ancient era in extreme detail for the very first time. But there's more to it, so keep watching till the end to know a lot more about this ambitious project that might change the way we look at the cosmos. It is vital for us to learn more about the cosmos, something that we know very little about. The technology of today and the laws of physics might be two of the only factors that make things difficult for us. But that is about to change now with a new telescope on the Moon. NASA is planning to place an ultra-long wavelength radio telescope in the far side of the Moon, which has tremendous advantages compared to the Earth-based and Earth-orbiting telescope. It all started in the year 1930, when a young radio engineer working at Bell Telephone Laboratories named Karl Jansky was given the task to find natural sources of interference that might mess up with communication systems back in the day. A pesky signal in their readings that would not go away turned out to be the radiation from the core of the Milky Way galaxy. While there were no stars, there was ample hydrogen during the universe's dark ages. Hydrogen that would eventually serve as the raw material for the first stars. With a sufficiently large radio telescope off Earth, we could track the processes that would lead to the formation of the first stars, maybe even find clues to the nature of dark matter, explained Joseph Lazio, radio astronomer at NASA's Jet Propulsion Laboratory and a member of the LCRT team. Today, the intensity of signals from space is measured in a unit called Jansky, named after Karl Jansky himself. Some of the earlier work on radio was focused on communications over extremely long wave transmission. Once we had access to better technology, the frequencies used in these systems grew shorter. As a result, today astronomers look at bodies over wavelengths of a centimeter or shorter. 10-meter wavelength is no longer a shortwave by today's standards, but back in the day when Jansky did his work, this was relatively short and hence the name stuck. The universe is always expanding. As a result, the wavelength of electromagnetic signals coming from ancient target stretches becoming longer. Radio signals from the cosmic dark ages are very long, which shouldn't be a surprise. The radio telescopes on Earth are unable to see this long wavelength, low frequency radiation, and these signals are reflected back to space by the ionosphere, which, if you didn't know already, is a layer of ions and electrons in the upper layers of our atmosphere. This reflection also allows shortwave radio, including ham radios or amateur radios, to broadcast over great distances. Human-made radio interference can also create problems for the sensitive astronomical equipment. Visitors to observatories with radio telescopes are usually asked to turn their phones to airplane mode in order to prevent interference with these instruments. Several ultra-sensitive instruments studying radiation from the older stars in the universe would need to be shielded from any stray electromagnetic radiation. So how can we solve this issue? Well, the solution to that would be building a massive radio telescope on the far side of the Moon instead of having it on Earth. But why are we planning to put a radio telescope on the lunar surface and not on Earth? Well, this has to do with the fact that radio telescopes on Earth cannot be used to study this mysterious period because the long wavelength radio waves from that time are reflected by layers of ions and electrons at the top of our atmosphere in a region known as the ionosphere. Radio signals from Earth can also interfere, completely blocking some of the faintest signals. There is no atmosphere on the Moon like what we have on Earth, so long wavelength radiation would fall effortlessly onto the 1 kilometer collector. Yes, you heard it right, 1 kilometer. The Moon also acts as a physical shield that isolates the lunar surface telescope from radio interfaces and noises from Earth-based sources, Earth-orbiting satellites, ionosphere, and Sun's radio noise during the lunar night. The lunar far side could also be prime real estate to carry out several unprecedented studies of the early universe. But what would happen once we set up human colonies or send robotic explorers on the other side of the Moon? Well, humans setting up colonies will still take a lot of time, making this one of the most silent spots in the solar system without interference. As of now, China is the only country and is exploring the far side of the Moon. So how will we construct such a massive equipment that too on the lunar surface? Sending humans to build such a complex structure would not be the best thing to do because of all the costs involved, and NASA will have to deal with several unnecessary risks. One way to do this would be using robotic technology combined with artificial intelligence at a significantly lower cost and much faster than humans ever can. To put things into perspective, the wire mesh for the radio telescope could be installed by robots, pulling away the harsh conditions of the far side of the Moon. This is not any wire mesh. We are talking about a 1-kilometer diameter wire mesh, which would be built using wall-climbing duaxle robots in a 3 to 5 kilometer diameter lunar crater on the far side of the moon with suitable depth to diameter ratio in the form of spherical cap reflector. This means that this lunar crater radio telescope will be the largest filled aperture radio telescope in the entire solar system. This also means that such a telescope can observe the universe at wavelengths greater than 10 meters or frequencies above 30 megahertz, which are usually reflected by Earth's atmosphere. This is also something largely unexplored by humans. The early stage NASA concept could see robots hanging wire machinery crater on the far side of the moon, creating a radio telescope to help learn more about the dawn of the universe. After several years put into development, the Lunar Crater Radio Telescope, or LCRT project, was awarded about $500,000 as it enters Phase 2 of NASA's Innovative Advanced Concepts program. The primary objective of the Lunar Creative Radio Telescope is to measure the long wavelength radio waves generated by the cosmic dark ages, which, for those of you who don't know, was a period that lasted for a few hundred million years right after the Big Bang and right before the first stars came into existence. Cosmologists know very little about this period, which is why it is high time for us to answer some of science's biggest mysteries, and all of the answers that we want will be in the long wavelength radio emissions generated by gas that would have filled the entire universe during that time. While there were no stars, there was ample hydrogen during the universe's dark ages. Hydrogen that would eventually serve as the raw material for the first stars, said Joseph Lazio, radio astronomer at NASA's Jet Propulsion Laboratory in Southern California and a member of the LCRT team. With a sufficiently large radio telescope off Earth, we could track the processes that would lead to the formation of the first stars, maybe even find clues to the nature of dark matter. Duaxle is a robotic concept that is still under development. It consists of 2 tethered rovers where one of them would stay on the edge of the crater and act as an anchor, while the other would travel down the crater's wall into the bowl to build the telescope. NASA might also require a separate special spacecraft that would deliver a wire mesh dish to the center of the crater that the robots would unfold and drag up the walls of the crater to anchor on the rim. Duaxle solves many of the problems associated with suspending such a large antenna inside a lunar crater, said Patrick McGarry, also a robotics technologist at GPL and a team member of the LCRT and Duaxle projects. Individual axle rovers can drive into the crater while tethered, connect to the wires, apply tension, and lift the wires to suspend the antenna. Once the Lunar Crater Radio Telescope becomes operational, this would allow astronomers to conduct extensive research on the ancient universe at wavelengths greater than 10 meters in detail for the very first time. These frequencies are also used on Earth in very high-frequency television broadcasts and shortwave radio. The bottom line is the team is already trying to make the Lunar Creature Radio Telescope a reality, where more than $500,000 had already been granted for developing the project. So this ambitious project is by far one of the most revolutionary proposals named in NASA's Innovative Advanced Concepts program. This program, for those of you who don't know, is responsible for some of the most bold ideas, including several early concepts in space exploration and astronomy. Such a large telescope on the far side of the moon would help scientists explore a range of radio wavelengths that they can't see from Earth, and would open the door to learning more about the dark ages of the universe, which is something that we need to know if we want to uncover the mysteries of the cosmos.